KMF has 6 sections devoted to the special exercises by test point. Today we will cover 5.2 and 5.3. Let us start with mean. Just satisfied that. Question number 3. At the end of each business day, the owners of stores X and Y calculate the total daily revenue received that day. For a 5 business day period, the average arithmetic mean total daily revenue was 6,000 for store X and 5,000 for store Y. Which of the following statements must be true? Indicate all such statements. So let us read the options. The total daily revenue of store X was greater than that of store Y for at least one of the 5 days. Now, the average total daily revenue for store X is greater than that of store Y. So, option A is correct. Option B. The total daily revenue of store X was greater than that of store Y for at least 2 of the 5 days. We don't know whether it was 2 of the 5 days or 3 of the 5 days, but we just know that it is greater at least for 1 of the 5 days. Right? So option B is not correct. Option C. The greatest total daily revenue of store X for the 5 days was greater than that of store Y. Okay, let us test it with numerical example. Suppose for X, the revenue average is 2.8. So we get 1 plus 2 plus 2 plus 3 plus 6. And for Y, we have taken 1 plus 1 plus 1 plus 1 plus 8. So in this case, we know that total daily revenue is greater than Y, that is 6 greater than Y, and yet the average, that is the arithmetic mean, is greater for X. So option C is not correct. We get only one option as the correct answer, that is option A. Let us move to median. Let us start with mean. Okay. So quantity A, the median of the first 999 positive even integers, and quantity B, the median of the first 999 positive odd integers. So in case of quantity A, we require first 999 even integers. The first even integer is 2 and the last even integer, that is 999, is 1000. So how to find out the median? That is the last term plus the first term divided by 2, because we have consecutive even numbers, right? So in case of consecutive even numbers or consecutive numbers, we can use this formula, last term plus first term divided by 2. So in case of quantity A, I got 1002 divided by 2 equal to 501. Similarly, in case of quantity B, the first even integer, it will be first odd integer and the last odd integer is 999 and the median is 500. So quantity A is greater. Okay, we are given 5 numbers: minus 0.5 to the power minus 2, minus 0.5 to the power minus 1, minus 0.5 to the power 0, minus 0.5 to the power 1, minus 0.5 square. So in this case, first we'll simplify those. So what are those? 0.5 whole square equal to 0.25. Right? So as there are minus before 0.5 and there are square, we get the plus sign. So we get the values 1 by 0.25, that is equal to 4, and minus 1 by 0.5, that is minus 2, and so on. And in this way, we get the highest number, that is 4, and we get the lowest number, that is minus 2. And what are we going to find out? What is the range of the 5 numbers listed? So range is 4 minus minus 2, because minus 2 is the least number, equal to 6. So option E is the correct answer. So to solve such a question, we need to simplify the values, and then we'll find out the highest value and the lowest value, and then we'll take the difference and we'll find the range. Listed above are the 16 grades on a chemistry examination before they were adjusted. The chemistry professor adjusted the grades by adding 8 points to each grade that were less than 60, adding 6 points to each grade that was at least 60 and less than 80, and adding 2 points to each grade that was at least 80. What was the range of the adjusted grades? So there are some grades 82, 90, 55, and the professor adjusted the grades. How? Those which are less than 60, he added 8 points with them. So suppose 55 is less than 60, so 55 plus 8. Okay, in this way, numbers that are less than 60, we will add 8 points. We will add 6 points to the number which are at least 60 and less than 80. So 75 is less than 80 and at least 60, so we will add 75 plus 6, and adding 2 points to each grade that was at least 80. So 87 is at least 80, so 87 plus 2 equal to 89. What was the range of the adjusted grades? And we need to find out the grades. That's the highest grade after adjustment minus lowest grades after adjustment. So 54 plus 8, because 54 is the lowest number in these grade points. We get 62, and 75 plus 6 equal to 81, 96 plus 2 equal to 98. So 98 is the highest number and 62 is the lowest number. We get range 36 by taking difference of 98 and 62. We do not need to change or adjust all the breakpoints. We can just identify with our number sense which one will be the greater and which one will be the lower. Right? So in this case, 54 is the lowest and 96 is the highest. Anyway, let us move to the next question. Let us move to median. We are dealing with quartiles and box plots now. The table above shows the number of points scored by a team in each of 48 games. What is the third quartile of the distribution of the data? So, how to find it out? There are various formula we can use. N plus 1 multiplied by 3 by 4, that is 48 plus 1, that is 49 multiplied by 3 by 4. Anyway, we get 36.75th term. So add 5 plus 8 plus 4 plus 15 plus 9, you will get the 36th or 37th term here. And what is the number point? That is 4. So the answer is 4. The box plot above summarizes a list of 240 numbers. Which of the following statements must be true? Indicate all such expressions. The list contains the number 60. We don't know whether the list contains the value 60. We just know a distribution. Range of the numbers in the list is less than 4 times the interquartile range of the numbers. Okay, let us calculate. Range of the numbers, what is it? Highest is 80 and lowest is 20. So 80 minus 20 equal to 60. 4 times. So 4 multiplied by what? Interquartile range. How to find it? That is Q3 minus Q1. So what is the Q3? That is 70 and Q1 is 40. So 70 minus 40 equal to 30. Is 60 less than 4 multiplied by 30? That is 120. Yes. So option B is the correct answer. Let us move to the next option. There are more numbers in the list that are less than 40. Then there are numbers that are greater than 70. We don't know whether there are less number that is less than, there are more number that is less than 40, or there are numbers that are greater than 70. We don't know about values. We just have a box plot that summarizes those values, right? So we cannot say whether C is correct or not. So option B is the correct answer in this case. So percentiles. of the 200 integers in a set, the 65th percentile is 20. Okay. Arithmetic mean of the integers in the set. The answer will be D. What's the reason? The same reason we couldn't say whether option C is correct or not in the last question. We're given percentile. We don't know about the values. How will we calculate the arithmetic mean? So the answer is D. The relationship cannot be determined from the given information. So, do we know their value? We just know that they are in the. We know they are in some percentile, that is 42, 48, but we don't know the value. So how can we find out whether R minus P or T minus A is greater or not greater? In this case also, the answer will be option D. The relationship cannot be determined from the given information. The dataset A and B are both normally distributed. In dataset A, 80, the mean is 60, standard deviation is 9, and 72 is qth percentile. In dataset B, mean is 70 and standard deviation is 6, and 78 is wth percentile. We need to find out the percentile. Okay, so let us draw. In case of A, 60 is mean, standard deviation is 9, so 60 plus 9, that is 69, first standard deviation. 69 plus 9, that is greater than, okay, that is 72. And this is in the second standard deviation. And in case of dataset B, the mean is 70, standard deviation is 6, so 70 plus 6. And we need to find out 78 is in the which percentile. So 76 plus 6. Okay, so this is also in the second standard deviation. So both are in the same percentile, that is within 95%. Yes, considering the both side positive and negative. So the answer will be option C. We have calculated or seen in which standard deviation these values fall, and then we have found the percentage. Here I have written some percentages for you. For the first standard deviation, we get 68%. That is mean plus standard deviation and mean minus standard deviation using both sides. And in case of second standard deviation, we get 95%. In case of third standard deviation, we get 99.7%, and the tail accounts for 0.15%. So let us deal with standard deviation. The standard deviation of the heights of 12 children whose mean height is 50 inches, the standard deviation of the heights of 10 children whose mean height is 60 inches. Okay, so we don't know what will be their standard deviation. We don't know about the values. Okay, we know about their mean, but we don't know their values, so we can't calculate the distance. So the answer is option D. Here we are given that mean x is equal to square root s by n, where s is the sum of the square differences, xa minus x whole square for 1 less than equal to y less than equal to n. The mean and standard deviation of the 17 values in a list are 0 and 40. Okay, standard deviation is 40 and the mean is 0 respectively. If one more values is included in the list, the mean of the 18 values will be 0. So mean is unchanged. So if mean is unchanged, which value have we added? The same value, that is equal to mean. Okay, The standard deviation of the 18 values will be closest to which of the following? We need to find out the standard deviation. Let us start. So now that deviation is xi minus x whole square. So standard deviation is 40. Let us make it square. So 40 square multiplied by 17. Why? Because there were 17 values in the list. And notice that the mean is unchanged because we have added the same value as the mean. As the mean is 0, we have added 0. So there is no changes. So now divide it by n. What is n now? That is 18. And then take the square root. We are using the formula root over s by n that is given in the question. So what is the answer? That is equal to 39. So 38 point something. So the answer will be option B, 39. For the numbers in set A, the average arithmetic mean is 5 and the standard deviation is 0.6. For the numbers in set B, the average arithmetic mean is 5 and the standard deviation is 0.7. Okay. Quantity A, the standard deviation of the numbers in A after each number in that set has been increased by 3 and the standard deviation of the numbers in B after each number in that set has been increased by 2. So in case of both A and B, there is no changes in the standard deviation because adding or subtracting a value doesn't change the standard deviation. Okay, so the standard deviation for A was 0.6 and for B it was 0.7. So the answer will be B is greater, 0.7 is greater. Standard deviation of the numbers 45, 64, 83 and 53 and the standard deviation of the numbers 55, 81, 47 and 62. Let us arrange the numbers in ascending or descending order and then we will find out the distance between the values and then we will compare quantity and B. So in case of quantity we have arranged it in ascending order 45 up to 83. And what is the distance between each number? 8, 9, 20. And in case of quantity B, we have arranged it from 47 to 81. And then we get 8, 7, and 19. So standard deviation of which quantity is greater? Obviously, it's A. Alternatively, what can I do? Find out the lowest number and the highest number. If the lowest number and highest number, range, the difference of those numbers are not same in case of quantity and B, then if range of A is greater than range of B, the standard deviation of A will be greater than the standard deviation of B. And if range are same for both quantity, then you need to arrange those in order and then find the distance and then compare. Okay, so alternative method is a shortcut trick for you. Here we are given two datasets. Quantity A, the standard deviation of dataset 1 and quantity B, the standard deviation of dataset 2. Okay, so if value is in distance with mean have lower frequency, standard deviation will be less. So what is the mean in case of dataset 1? We know that it is almost a normal distribution. So mean will be 17. Okay. So take the distance from the mean 16, 18. Okay, almost near to mean, and the highest distance is 15 and 19. You have only one frequency of 15 and 19. And what is the mean in case of dataset 2? It might be 17 also. So what is the has distance 15 and 19, and they have 3 plus 3 equal to 6 frequencies. So the standard deviation of B will be higher. Okay, if values in distance with mean have low frequency, standard deviation will be less, and if values in distance with mean have higher frequency that the dataset 2 has, then the standard deviation will be high. Okay. So we are given 4 sets here. Which of the following statement illustrates the exact order of the standard deviation of these sets of numbers from the lowest to the greatest? Notice that 9, 13, 4, 2. These 4 numbers are common to all data sets, and the last digit or last number is different. Let us find out the mean of 9, 13, 4 and 2, and then we will take the distance, and it will lead us to arrange the order of the standard deviation of these sets. So the mean is 7. So A, what is the standard deviation from mean? 7 to 7, there is 0. In case of B, there is 7 to 9, 2. In case of C, 3. In case of D, it's 1. So the order will be what? 0, 1, 2, 3. A, D, B, C. So option E is the correct answer because we are arranging it from the lowest to the greatest. Here we are given that mean x is equal to square root s by n, where s is the sum of the square differences xa minus x whole square for 1 less than equal to I less than equal to n. The mean and standard deviation of the 17 values in a list are 0 and 40. Okay, standard deviation is 40 and the mean is 0 respectively. If one more values is included in the list, the mean of the 18 values will be 0. So mean is unchanged. So if mean is unchanged, which value have we added? The same value, that is equal to mean. Okay, the standard deviation of the 18 values will be closest to which of the following? We need to find out the standard deviation. Let us start. So now that deviation is xi minus x whole square. So standard deviation is 40. Let us make it square. So 40 square multiplied by 17. Why? Because there were a research report states the average arithmetic mean of 120 measurements was 72.5. The greatest of the 120 measurements was 92.8, and the range of the 120 measures was 51.6. The information given above is sufficient to determine the value of which of the following statistics. List of the 120 measures. Okay, greatest number is given, range is given. So range minus greatest, we can find out the list number. Okay, it's fine. It's option A. The median of the 120 measurements. We don't know the median because we don't know value. The standard deviation, can you find it out? Not possible. The sum of the 120 measures. Okay, it's possible because we know the mean, we know there are 120 measures, so sum is possible. Option A and D is the correct. As a part of an environmental study of a river, a random sample of trout was drawn from the river and the length of the trout was recorded. The average arithmetic mean length was 14.31 inches. If a length of 16.89 inches was 1.50 standard deviations above the average, what was the standard deviation of the lengths of the trout and the sample? So, length is 16.89 and the standard deviation is 1.50 and average is 14.31. So now take a difference 16.89 and the average is 14.31 equal to 2.58. Okay, and the standard deviation is 1.5. So divide 2.58 by 1.5, we get 1.72. So the standard deviation of the length of this drought in the sample is 1.72. We're given a normal distribution curve, bell-shaped curve. The figure above shows a normal distribution with mean m and standard deviation d, including approximate percent of the distribution corresponding to the 6 regions shown. A survey of 5,500 book readers found that the number of books read per year was approximately normally distributed with mean 19 and standard deviation 2. Which of the following is the best description of the numbers of books read per year by the 880 book readers who read the most books? Okay, so mean is 19, m equal to 19, and standard deviation is 2. So 19 plus 2 equal to 21, and 21 plus 2 is 23. Now, what is the percentage? 880 books readers who read the most book, and total is 5,500. So get 16%. Now put your pen in the right side of the bell-shaped curve and move towards the left side. In this way, you'll get that the percent will start from the 21, right? So 14 plus 2 or 2 plus 14 equal to 16. So 23 is just before the 2%, within the 14%. Sorry, just in the bar, that is between 14% and 2%. But we are given that the percent is 16. The option C will be the correct answer, 21 or more books. So probability distribution. The probability distribution function f of a continuous random variable x is defined by fx equal to 2 by 13 multiplied by absolute x. 4 minus 3 less than equal to x less than equal to 2. Quantity A, the median of the distribution of x. So put each value in case of insert each value of x. What are the values? Minus 3, minus 2, minus 1, 0, 1 and 2. So put those, arrange in orders, and then you will get the median. Minus 3, minus 2, 1, 0, 1, 2, 6 numbers. So third and fourth value will be the median. So in this case, you will get that median of distribution x is greater, because due to absolute sign, all value will be positive. However, as the range contains 0, we will get 0 and positive numbers, right? And quantity B contains the negative numbers. In this way, if we do not insert all values for x, we can answer the question by logic only. Okay, so as quantity A will be either 0 or positive number, median will be median of the quantity A is greater than the quantity B, that is minus 9 by 5. Okay, that's all for today. Thanks for watching. This video is helpful to you. Please subscribe the channel and share with your friends and acquaintances. Thank you for watching and your patience.